in class, we went through the derivation of all of these various statistics, descriptive statistics, as we call them, because they describe the population of the sample. Okay, and we learned how to calculate the mean, find the difference between the mean and each individual value, square that, add them up for the sum of squares, divide by n minus 1 for the variance, and square root for the standard deviation. We learned how to do all of that. However, not likely you're going to be asked to do that on a test, because Excel is going to help you out with that by having specific functions for each of these descriptive statistics. For instance, if you want to calculate the mean, type in an equal sign, type in average, unfortunately, they don't call it the mean, they call it average, highlight, or type in the range of numbers that are represented that you want to find the mean of, and hit enter. The median also has its own function. Median, these numbers, again. Okay, the mode has its own function. Okay, you see me using shortcuts here to put in the ranges and so on and so forth. Minimum. Hopefully you remember how to do that. Or you could just type them in, A1 colon A10, if you don't remember how to do that, or you don't feel as comfortable with the with your trackpad or the mouse or something like that to indicate the range. Whoops, made a mistake there. Let me get away with something there. And the mistake I made was the function is not minimum, it's min. Hit enter, and the way I should have recognized that right away, if I type in equal signs when I go to maximum here, as soon as I get to the X, if I type in maximum and put in parentheses, nothing happens. It's not waiting for me to put any values in. But so I know something's wrong. If I had put in max and put in parentheses, it should prompt me for now I'm ready for the values that you want to enter. So you can avoid that and make sure you can back it up and put in the right function. And for range is just the difference between the minimum and the maximum. So I'm going to put equals. I'm going to go to maximum because that's the higher number minus the minimum. And the range is 10, value 10. Okay, now the variance equals VAR. Now you could use various of these as a variance of the population. That divides by n. This is the variance of the statistics, of the sample rather. That divides by n minus 1. There's reasons for doing it that way. But, usually you're doing variance of statistics of a sample, right? Because you usually don't know the whole population. You can avoid this whole issue by just typing in VAR, parentheses, and it's ready to take it anyway. It's going to use the default, which is the variance of the sample. Okay, and I'm going to hit enter. And the standard deviation is the square root of the variance. So there's two ways I could do this. One way is to just say square root, that happens to be the function, SQRT for square root, parentheses, I know I got it right because it's ready for a number. I click there to tell it the square root value in that box. It tells me it's 3.64. Alternatively, I could use the standard deviation. Again, it's going to ask me, for the sample, for the population. I could shortcut that. Just put the parentheses in, STDEV if you want. You could use, if you want, you could use the S version of it there. But either way, I'm going to highlight that, hit enter, and it comes out the same number because it's literally just the square root of the variance. Now, percentiles. You remember when we talked about the that precedence chart? We talked about the idea that you got the median is the 15th percentile. The 25th percentile means there's 25% of the values are below that, 75 above. 75th percentile is the opposite, 75% below, 25% above. So I'm going to find the 25th percentile by using a function in Excel, percentile. Okay, and for our purposes, I just could put a percentage in. I just put our bracket in because it's ready at this point to just give its default value for percentile. So what you got to tell it for percentile is you got to tell it what numbers you want to find the percentile of, and that's just the array. I'm going to highlight all these guys. Okay, it works across several rows or columns too if you want it to, if you have like a large array of numbers. Then I'm going to type comma, and then for K, I'm going to type in the percentile that I want. Now it's expecting it as a decimal point, 0.25, 25th percentile, and I'm going to hit enter. And 67 happens to be the 25th percentile. 25% of the value is below, 75% above. 75th percentile, I'm going to do the same thing. Okay, the array is all these numbers, comma, 0.75. Now, if you don't remember that, you can go up to this little f of x symbol up here. Click on it, type in percentile, tell it to search for percentile, and click on help, and it will describe to you how that function works and what it's expecting, what form it expects the information in, whether it's as a percentage or whether it's as a decimal point. Excuse me. Okay, so now the interquartile range. Well, that's the range between that's the middle 50% of the values. That's the range between the 25th percentile and the 75th percentile. Kind of the way the range is the difference between the minimum and the maximum. So that's going to be equal to the bigger value, 75th percentile, minus the smaller value. That's going to be equal to 6, just as we found there. Okay, so hopefully you'll be able to, if that comes up, you'll be able to use Excel to do this efficiently rather than use a calculator or something like that. Okay, so now we then asked you to repeat the calculations and using some other function. I don't know if you're going to have to do that or not on the exam, but I'm going to go ahead and give that a try right now. Okay, so now most likely you will be given delete. Okay, most likely you will be given a separate data file to import into SPSS or Excel. I'm just going to save this on my desktop just to show you that you can actually do this. I'm going to save it. Then I'm going to open up SPSS and I'm going to import the file into SPSS. Most likely you won't be asked to import a file from one format to change the format of a file like this. You'll just be given what you need, what file you need. Okay, but I'm going to go ahead and import this. Now you could even just, it's 10 numbers, you could have even just typed them into Excel, into SPSS, if I can ever find SPSS. Here we go. Okay, so I'm going to import this data from the Excel file into SPSS. You may remember that at the top, this is just a list of 12 numbers. I deleted everything else. It's just a list of 10 numbers rather. Now, at the top of those, the first row, there was no description. It didn't say like blood pressure and then list 10 numbers. It was just the 10 numbers. That's going to be important to us when SPSS eventually opens up. Okay, and that takes a little while. There's a lot of, I guess, a lot of legacy code in this program. The program's been around for a long time. IBM just bought up the company about maybe 6 or 7 years ago. And I don't think they've really spent all that much time trimming down this program because it still takes a long time for it to open. So I'm going to move on. While that's working on that, I'm going to just see if there's something else. Okay, I think that's it for assignment 1. So when it eventually opens, we'll get to that. Here we go. Might have been waiting for me to click that start page. I usually just get rid of this and I just say open data. And I go to my desktop. Long way to my desktop here. Okay, and it's looking for my Excel file. I don't see my Excel file. The reason why I don't see my Excel file is it's only looking for SPSS files, .sav. So I can tell it, now I got an Excel file I want to import. And now I can see that Excel file, Descriptive Statistics. So it's going to import that Excel file. Okay, it sees the data in the range of A1 to A18. There must have been a number I didn't delete there somewhere. I'm going to ask it to import it. Okay, I don't see any there. Yeah, there was some blank spaces. There's really nothing in those things, right? There's nothing there. I'm just going to highlight those and clear. Okay, so there's only oops. Did I take one too many? Well, there were only 9. Oh, you know what happened there? I did exactly what I told you guys not to do. I'm going to open it again. Open data. Probably a couple of you guys saw what I did there, right? I went too quick. Double click this. It wants to import this. Now, read variable names from the first row of data. Well, there is no variable name in the first row of data. It's part of the data. That's why instead of importing 10 numbers, only imported 9. It figured that other number must be something associated with the data. So I'm going to unclick that so it knows all of that stuff is data. And it'll open up again. This time we have all 10 of our values. It gives it a default variable name of V1. Okay, so now I'm going to go into, now I want to analyze this data. Again, there must have been some blank spaces in there, so I'm going to just clear that. I can see the numbers are darker there, so it thinks there's some data there. So again, you won't have this problem. So I'm going to say I want to find out more about this statistics. I want to know. Let me just check the chat box in case there's any question. Did I answer that question, Nicole, about when to check it? I think so, right? You uncheck it. You check it when the first row has the variable name in it, like age or gender or something like that. You uncheck it when the row in Excel doesn't have any data. But again, I don't think that's going to be relevant for the test. Okay, so let me go back here. So I'm going to analyze this data. So there's a few things I can do here. Now, by default, you're going to say to yourself, I'm going to analyze data. So what's the most reasonable place to go? Let's go to analyze. I'm going to go to analyze. And since we're talking about descriptive statistics, I'm going to go to descriptive statistics. And I see I have various choices. I have frequency, descriptives, and explore. Frequency just does a count. For instance, if this were male and female, 1s and 2s, it would count how many 1s there are, how many 2s there are. If you need to do that, that would be where you would want to go. In this case, I'm going to look for, it's a numerical variable, I'm going to look for mean, median, average, so on and so forth, standard deviation. So I'm going to go down to this second bar, descriptives. Okay, and there's only one variable here, so it's an easy choice. But SPSS, when it opens up a window like this for you to tell it what variable you want to work with. Say there had been, for instance, this might be age. Next variable might be blood pressure. Next variable might be BMI. You would see 3 variables show up here. If you want the descriptors for all 3, you move all 3 in. If you just wanted it for age, you click this and move this in. Okay, so now you click in options. And options asks you, well, what do you want me to do with this thing? Well, we want to get the descriptive statistics. We want the mean, standard deviation, minimum, maximum. Let's get the variance, and so on and so forth. Let's get the range too, but who cares? It's going to do it for us. Might as well. Say OK and OK. SPSS starts out by giving you what you would have to do this procedure using its basically kind of a programming language or instructional language, and then actually gives you the result. There were 10 values. The range was 10. Remember, we calculated the range, and minimum value was 65, maximum value was 75. The mean was 69.8. The standard deviation was 3 and these are the numbers that we got before when we used our Excel. So you could literally just click this, say copy, and you could paste this into a Word file or a document that you could then send to someone, include in a report, and so on and so forth. Let me see if there's any questions at this stage. Okay, good. I'm going to move on. Okay, so now if you wanted more detailed statistics than this, you don't have to, but I'm going to go back to the data page. I'm going to click on Analyze, Descriptive Statistics. I'm going to go down to the next choice, which is Explore. It basically is asking you for similar information, which variable you want to work with. The variable I want to work with is this one, which is the age, which I just imported. Okay, whatever it happens to be, maybe age. I'm going to move it in there, and I'm going to click on Statistics, and it's already set up to do all the statistics, like the descriptive statistics. It will also do plots for me. As it happens, it will automatically do a box plot. It'll also do some other plots as well. If you want, you can ask it to do a histogram for this data as well. It'll use its default values, but it'll create the histogram for you. Now, you can tell it to give you only the graphs, the plots and only the statistics, or both. I'm going to click OK. and it's going to go through the calculation. My output window is going to come up again, right? Here's my output window. And now, look, we have so much more information here. We have the median, variance. We have something called the confidence interval. You'll learn about that later on. So the range, the minimum, the maximum, the interquartile range. You have a histogram that's produced. Doesn't look very normal, does it? And you have a box plot. Now, box plots, the bottom leaf is the minimum value. The top leaf is the maximum value. You can see that right in the data. Sometimes, if there's a lot of values that are far away from the median, SPSS will show them as outliers, as values that might be an error that you should examine. You'll see them as either stars or circles outside of this range. But if there are no outliers, the top leaf is the maximum value, the bottom leaf is the minimum. There are outliers. I believe it's something like 1.5 standard deviations above the 75%. There's a rule that SPSS uses to determine whether it's an outlier or not. It's basically how far away from this range of the other numbers that it is. Not important for us right now what exactly the rule is. You can actually alter that rule yourself too. So you'll see the black bar in the middle is the median. This part, the bottom of the grayed out box, that is the 25th percentile. The top of the grayed out box is the 75th percentile. That was about 73, right? And the range, and this range from the 25th percentile to the 75th percentile is called the interquartile range. Okay, so that's something we learn from a box plot. Okay, so now I'm going to show you one other way to use this, and then we'll move on. I'm not going to bother saving this output window. I'm going to open another file. North Carolina, let's see, NC birth data, NC birth mod 800, I think it was, birth 800. I can't find it, SAV. Kind of version of it that see if that opens up. Nope, not very successfully. NC birth 800. I have so many versions of this stuff on here from the previous semesters. Mod.sav. See if that'll do it. Oh, I see some. Because I can't open this here. Oh, I think we're successful here. Oh, well, look at this data. We have 800 births in North Carolina. I think it was sometime in the last about 10, 15 years ago that this data is gathered from. It's got for each subject, for each birth, it's got the sex of the baby, how many babies, plurality is how many babies were born during that delivery, the mother's age, the weeks of gestation, marital status. Marital status, this is really, entered as a number. For instance, I could go over here and turn off the value labels, and you see it's really a number. 1, I guess, is married. And if I go back to view, I can turn that back on in case you're not sure which one is which. Okay, so I can do statistics on any one of these values as well. So the descriptive statistics usually is limited to numerical variables, just as frequencies are normally done only for categorical variables. So for instance, I might want to go over here and say analyze descriptive statistics, frequencies. I wouldn't want to do that for the age of the mother, because then it's going to give me how many mothers were 32, 33, 34, 35. That's kind of like not going to be very informative. However, I might want to do it for the marital status, because that'll tell me how many mothers are within a certain, how many mothers are married, how many mothers are not married. Here, frequency 537, married mothers 263, unmarried mothers, the percentages of each, and so on and so forth. I could even do a graph in here, legacy dialogues. I'm going to go back down here to, I'm not going to, actually, let me see if I can't do it from analyze. Frequencies, charts. Let's do a bar chart. Okay, bar chart would be would be a histogram because we're not talking about a numerical variable. Okay, and it'll give me the data I just got, plus it'll give me a nice bar chart so I can see relatively how many married versus unmarried mothers there were during that period in North Carolina. Right, so that's a good use of the frequency choice in descriptive statistics. Now I'm going to go down to descriptive statistics, descriptives, and I'm going to take a look at a numerical variable such as the amount of weight gain during pregnancy. I'm going to move that in here because that's the one I want to work with. Let's see what my options are. Well, my options mean, medium, so on and so forth, range. I'll check them off. Why not? I'll click continue and say OK. Okay, and it will give me that information. Let's see. The mean weight gain during pregnancy is 777 grams. I guess, what is that, grams, I guess? Oh, that's the number of women. The weight gain during pregnancy, the average is 30.58 pounds, I guess. Minimum was 0. Maximum was 95 pounds. That's some sort of outlier. We don't know what that means. Maybe it's the data is incorrect, and maybe it wasn't there. Standard deviation, variance for the weight gain during pregnancy. Gives us an idea of the distribution of weight gain during pregnancy for this sample of 777 women. Okay, so now if I go back up here, analyze descriptive statistics, frequency is good for categorical variables, nominal variables, because it does a count. Descriptives is good for telling us about the entire range of weights. Well, let's see. Let's say if I wanted to compare the weight gain for married women versus unmarried women. Well, now I can't look at all 777 women within the same group anymore. I want to split them up into two groups. Splitting something up, another word for that is factoring. So I'm going to go in here and say descriptive statistics. Descriptive just looks at them all as one group. I'm going to go into explore, see if that'll help me out. And in fact, oh look, okay, let's put the dependence list. That's where we're going to put the weight gain during pregnancy. I'm going to move that in there. But now I'm going to tell it, I want you to break that up based on the marital status of the mother. Well, that's going to say, don't do just the statistics for all of the women together, separate it into the two groups, and then do the statistics. I can make the same choices here, make sure it's going to do descriptives. I can tell it to do various plots, do histograms, for instance. Okay, and it's automatically going to do box plots. In fact, it's going to do a very nice thing with the box plots we're going to see in a second. I'm going to click OK. And sure enough, here, instead of just getting the statistics for all of the women, it's split it up by married and unmarried. And let's see if I can see a difference. The average weight gain during pregnancy for married women was 30.56. For not married women, it's 30.63. Looks like there's no difference, right? I mean, we have all the other statistics here, gives how variable it was for these women, but don't look like there's much of a difference in weight gain. So that's interesting. We learned something. Okay, if we want to see it graphically, let's see. If we look over here, oh, well, look, it looks fairly normally distributed. However, this is for married women. However, some women gained a lot more weight. So at the average, probably, if I were to describe this distribution, this histogram, I would say it was positively or right skewed. Okay, probably same thing. Probably looks the same way. Again, this for not women, we see that also, right? Not many women gain very little weight or no weight during pregnancy. Some women gain a lot of weight during pregnancy. Okay, so, and the box plot here, let's take a look at it. You know, as expected, the medians look pretty similar. This is a side-by-side box plot. Nice to be able to compare these two groups side by side like this, right? This is the interquartile range. It's from this number, 21, to about 40. About the same range here, maybe a little bit wider, from about 21 to about 42 or something like that. Okay, you'll notice this was the lowest value was 0. The highest value, well, you know, the highest value was really 750, but it's probably something wrong with that, right? I would think was 90 pounds, right? That 750 is the line number, is the subject line number on the graph. It's the 750th person down on our SPSS chart, on our data window. Okay, this is the 7th person down. Right, they were like, looks like about 75 pounds or something like that. We can actually check that. So these were what SPSS considered outliers, right? The feathers represent what the data that it's working with that it thinks is the minimum and maximum, right? And 75th percentile, 25th percentile, median. Okay, so now let me just take a look at that seventh person and see if that's really true. Seventh person is this one, and the weight gain was indeed 75 pounds, as we suspected. Is the factor an independent variable? Independent, it's a variable, right? It's a numerical variable. When you talk about independent variable, is it independent? Is it? I'm not sure it's really relevant in this context, because all we're doing is looking at the distribution of all of the weight gains for all these pregnant women. Where that issue would be important is later on if we're trying to understand the probabilities of things happening. For instance, is it independent of whether the mother was a smoker or a non-smoker? Is it independent, and so on and so forth. So I wouldn't worry about it in this context. I think later on when we start talking about probability, when you sample something, or you're trying to determine a probability, you want to make sure that, for instance, if I randomly sample 10 people from a population, that your sampling technique is random and independent. So, like in other words, it's random, so you don't favor any person in that population that you're sampling from over anybody else, and also that it's independent, so that one person is not somehow or other related to another. So, in other words, you don't sample, for instance, the next 10 people that walk up the street. That might be a random sample because, I mean, could be anybody walking up the street, but it's not really, the people are not really independent because there's a good shot that if they're walking together, they're related. So it's not the same as making sure that even though you might sample them randomly, that they're not related, related in some way, related physically or related some other way. Right. So I think that really is a good question, but not in this particular case. That's really an issue. That's really an issue for whether or not they sampled this. Remember, this is only 800 births. There could be 1 million births. So that's a good question in terms of how did they get these 800 women? Did they randomly? Was this all during the course of 1 month in North Carolina? Was it at one hospital during the course of a year, and so on? So in which case, maybe it wouldn't be independent. Maybe same families go to the same hospital, and so on and so forth. Maybe the data is not really independent, right? Or maybe for it to be random, they would have to randomly sample hospitals from all over the state and so on. So I'm getting a little bit of a tangent from this. We don't have too much time, so I want to move on for it. But that's an excellent question, and it impacts us in so many different ways. Okay, so I'm going to move out of this, and just so you can get. So really, with SPSS, we're mostly using this analyze. We're analyzing descriptive statistics frequencies when we do account nominal variables, or we want to produce a bar chart. We're using descriptives when we want to find the descriptive statistics for one uniform variable for everybody. And we use explore when we want to break it up into groups, subgroups, by a nominal variable like gender or income group or ethnicity or something like that. Those are all nominal groups. And also if we want to get a bit more detailed statistics as well. And again, it'll produce a box plot for you and side-by-side box plots if you want. Okay, so let's see. So where was I now? So I'm going to go over quickly to homework number 2. Okay, I'm going to run through that quickly. Okay, so now let's take a look at this. Population mean is known to be 160. Standard deviation is 30. I'm assuming that some of this material is going to be on the exam. I don't know for sure how much. I'm not making up the exam. I haven't seen it yet. I do know Professor Waldron has mentioned that he expects to cover material for session 1 through session 4. I suspect he might not concentrate too much on the most recent stuff that we did because we maybe haven't had a chance to really get to it. But I want to make sure we cover some of this stuff. Population means 160, standard deviation 30. What's the probability that a single observation selected at random from the population would have a value of 130? Okay, well, let's see. What is that? How would we handle that? Well, this is, I don't think I gave you the name of this idea. Let me see. I think I actually have one that is a better, but maybe this one. Yeah, this one's better. Okay, you guys may remember that we referred to this. Did we give this a name in class? This estimation of how the population or sample is distributed in a normal distribution. Did we give this a name? This rule of 68%, 98%, 99.7%. I don't know if we gave it a name or not. I may be being a little bit old-fashioned here, but yeah, it is a bell curve. But this idea, this rule, that they normally distributed distribution, that you can often find that 68% of the people or samples or population is between one standard deviation below the mean and one standard deviation above the mean, and 95% is within 2 standard deviations above and below. That idea is called the empirical formula. Okay, that's the empirical formula. Empirical means, anybody know what the word empirical means? Empirical means kind of based on experience or experimentation, right? So it means that it's not necessarily a perfect way of doing it. It's not the most accurate way of doing it, but it's an estimate or something that generally proves to be true. So this is an empirical formula. Not always true, not always perfect, but it's a pretty good guide, right? So the first question I asked you, the mean was 160, right? And well, let me get this out of the way for now. Let me go back to this. Mean was 160. Standard deviation is 30. What if you took a single person? What's the probability they'd have a value of value of 130 or less? 130. Let's say less, right? Less than 130. Okay, good. So sigma, that's our standard deviation, is equal to 30. Okay, now, first of all, I'm using mu and sigma. Mu and sigma. If I'm using mu and sigma, am I referring to the population or a sample? Are you ready? Hard to guess now? Right. No. Not referring to a sample. I'm referring to, anytime I use Greek letters, I'm referring to the entire population. Those are called parameters, in case that word comes up. Okay, if I say X bar is equal to 160 and S, the standard deviation, is equal to 30, then I'm referring to a statistic. And I'm working with a sample. Okay, parameter, Greek letters, and deals with the population. X bar and S, statistic, and deals with the sample rather than the population. Okay, so at any rate, that aside, 160 standard deviation to 30. So the mean is 160. Well, what the standard deviation is 30. So one standard deviation below the mean would be 130. One standard deviation above the mean would be, would be 190. So what's the probability of picking out someone that's under 130? Maybe this is weight. Maybe weighs under 130 pounds. Okay, well, 30. Let's see, 13 points. 13. This 13.1. I'm going to call this 68% rather than this. So let's see. If this is 68%, that makes this side 34%, right? That makes this whole end here only 16%. Everybody get that idea? If this is 68%, right, then the half from this side of the mean here is 34, and half from this side here is 34, because we know that this is symmetrical. Okay? Since it's symmetrical, I can assume that this half is 34%, this half is 34. So that means there's 16% left to the left and 16% left to the right. That all adds up to 100%. Okay, so now 16% of the population is under 130 pounds based on this information. Now, when I say what's the probability of sampling one person at random, or three people randomly and independently, or whatever, what's the probability of that person being under 130 pounds? Well, the probability, since 16% of the people are under 130 pounds, that probability of sampling, of getting that one person from that group, is going to be 16%. Or probability equals 16.16. Probability of being x being less than 130 equals 0.16. Okay, so we can manipulate this a million ways. I'm not going to go through every problem here, but if you guys had one of these that you had an issue with, just let me know. Let's see if I can get one that's a little complicated rather than go through every one of them. Okay, here. For the same population, what is the probability of selecting one individual from the population as a value less than 130 or greater than 190? Okay, and in this, I asked you to use the empirical formula specifically. Other ways we can do this, as we'll see. Okay, so let's see. I'm gonna move over here and get a fresh piece of paper, and let's see. I'm gonna say that. Let's see. Our mean is 160, right? This is one standard deviation. That's 130. Two standard deviations below is going to be 100. One standard deviation above is going to be 90. And two standard deviations above is going to be 220, I think, right? Did I screw that up? Nope, I didn't, I don't think. So what did I just ask you? What's the probability of randomly selecting an individual, or what percentage of the population, same idea, is below 130 or above 190? Right? Well, let's see. We already know this is going to be 34%. This is going to be 34%, right? Because they're inside that one standard deviation. That's going to leave 16% below and 16% above. So that's going to leave these so the two areas that'll satisfy this are these two outside areas here. So that's going to be 32%, or the probability is going to be 0.32. Okay. So now, what if I ask it slightly differently? I'm going to do this again. Maybe it can. Let me undo a lot of this. There we go. Good. That worked out okay. Okay, let's say I asked you what percent of the population is less than 130 or more than 220. Okay, let's see what that is. Well, this is one standard deviation. This is, we know again, we've done this before, 16%. And what percentage of the population is above 220? Well, 220 is two standard deviations. So we're talking about this area here. It looks like a pretty small area, right? That's why it's nice to sketch this out. Harder to get it wrong if you sketch it out, because you'll see if I wound up thinking, oh, more than 220, that's 80% of the population. Oh, something wrong there, because that's a small area. Right? What are these two areas combined then to answer this question? This is 16%. Okay, 160, 190, that's two standard deviations. Well, I know two standard deviations overall represents 95% of the distribution. Right? That means that from the mean to here represents 47.5%. Right? That's half of the 95%. That leaves 2.5% above this. So this area is 2.5%. So the areas that satisfy less than 130 and more than 220 is going to be 16% plus 2.5, or 18.5%. there's all sorts of ways. If you can imagine, there's all sorts of things I could ask you. What's the probability of being between 130 and 220? You could answer that almost immediately, couldn't you? The probability of being in this area here is just the probability of not being in these areas. So it's going to be 100% minus 18.5%. Could have figured it out that way too. 18.5%, right? Or was that 81.5%, or 0.815, right? So you could do all sorts of. Oh, good. I'm glad somebody mentioned something that there's a particular problem. Okay, so I'm not going to beat this to death. So we're going to move on to some other stuff. Okay, but I did get a question about number 15. Yeah, I'm going to get to the binomial. Haven't forgotten that one.